search them, facilitators, broker. In access, you need to enable and obtain access and build the infrastructure so access happens. In understanding, data needs to be annotated, it needs to be translated and interpreted, and matching needs to happen. And finally, there's the policy side. Now, in this talk, I'm going to primarily focus on policy problems. But policy really undercuts each of the other three areas, and there are a lot of problems that I'm not going to be explicitly talking about, but that will come up if you actually look at each of those areas. Okay, so what inhibits sharing? Why doesn't sharing happen today? Well, first of all, consumers are unaware of data that they need. This is really a question of discovery and access, that people don't know each other's needs or what data is out there. There's a second problem, that is that consumers' information requests are ignored if they don't have the correct privileges. This is a policy problem, that providers today assess risks and need to know ahead of time, but they don't know what situations are going to develop. They don't know who's going to actually need the information. Individuals, on the other hand, they may have critical need for data, but they don't have the right privileges. And these situations, in all the scenarios I've described, these problems come up. And finally, there are other reasons of not being aware of context, of lacking sharing systems. And if you took a group of people and asked them, why doesn't sharing happen? Chances are every one of them will point to a different reason and claim that is the real reason sharing doesn't happen. And I think the real answer is that all of these are important. You need to address all of these for sharing to happen effectively. Again, in this talk, I'm going to focus primarily on policy. Let me first before getting into technical problems, let me first throw up a laundry list of problems that people face in the field of technologies that they need for sharing. So the first problem, of course, is protection for data at rest. Once you share data and it goes to the other person's system, it's at risk over there. It's susceptible to compromise and it needs to be protected. Data that is shared can itself have attack vectors in it, so you need to protect against data-driven attacks. There's a whole range of problems that come about over here, and I'm not actually going to walk through all of them. I'll just talk to a few of them. So the third one is to detect exfiltration or hidden data. Now, this hidden data can be deliberate in the form of steganography, it can be malicious, or it can be accidental. And when you send a Microsoft Office document across the wire, chances are it contains objects that keep track of the entire history of edits you made to that document. Now, Microsoft has been working on tools to fix this, and the tools are available, but there are a lot of formats out there where you have a lot of legacy objects that are in the formats. The development teams today don't know what those formats are. So they just leave the objects in the representation. They don't want to delete them because that breaks certain applications. They're just left in there. And somebody who really understands those bits can actually extract what was there in the history of that document. And lots of sensitive data has been leaked in the past because of this. And it happens all the time. Companies send documents to other companies, it contains hidden documents, hidden data, and they get into problems. So we really need techniques to be able to detect this hidden data and to extract it and filter it out of these representations. Spillage, that's the last bullet over there. That one of the main things is that when data does get spilled, it compromises systems, and we need to be able to detect that and clean up after spills. Okay, let me actually move into the three areas of interest to us at present. And before I actually go into these, let me give an overview of the motivation of our approach. So when I began the talk, I motivated the problem as saying that what we're really talking about is a world where we have a social network, and we want to allow people who don't know each other to actually share data and communicate and collaborate. Now, the entire history of access control that we've been progressing along has been based on building finer and finer-grained access control mechanisms. And what these are designed to do, actually, is to block those unintended connections. So the perspective of this project, which we've taken, is really to take the counter approach and say, let's say we have coarse-grained access controls. We have communities, and we have a coarse-grained access control policy through which we admit participants into this community. and the community has a set of shared data within it. How do we now manage policy within this community? So every member of this community is allowed in principle to access all the documents within it, but we still want to have policies that constrain their behavior, and we still want to manage what sharing transactions happen. So there are three problems that come about and three observations I can make. The first is that what we would like to do is to be able to make trade-offs between risks and benefits of sharing. So if a particular participant in this community tries to access a document, what we would like to do is understand why is he accessing it, what are the risks, what are the benefits, and make access control decisions based on that. The second problem is that all the technologies that we have today, security guards, firewalls, access control policies, they are fundamentally designed to block risky transactions. And what we really need if we're talking of sharing is we need a set of mechanisms that enable sharing. And the third problem is that the data that we're talking about really often doesn't have a single owner. Current mechanisms tend to take the approach that data is owned by the producers, and the policies are designed to protect the rights of those producers. And what we need are techniques that really have a symmetry. They protect both the rights of the producers and the consumers and other parties who are involved. So I'm going to talk about all three of these in the remaining slides. The first problem, of course, is this notion of risk-adaptive security. Now, the government has proposed this notion of RADAC, which is risk-adaptive access control, where the idea is that you vary access that's granted based on the changing threat level, the changing situation, authentication strength, and so on. And similarly, people have proposed having dynamically tunable auditing, where if you have weaker authentication, you get stronger auditing. If you have fewer privileges, then you get stronger auditing, and so on. And the question, of course, is this too complex? Can we really build such a system and have meaningful properties that we can say about it? So what we really need to do is to understand what are mission risks and what are the benefits. So we want to have mission risks include things like, is there too much sharing or too little sharing? Because too little sharing can be just as bad as too much sharing. They're typically blunders that lead to spills. People have unapproved workarounds where they deliberately try and get information shared in violation of the rules because it's blocking their capabilities. Certain capabilities may be insecure, or they may not be perfectly secure. And what we need to do is understand how do all these things interact and how do we actually make these risk-benefit decisions. Now, there have been lots of approaches that people have proposed to do this. The first one is the simplest approach, but this is the one that's gaining traction in the government today, and that is to really use attribute-based access control. So the idea is you have attributes that represent both the risks and situational benefits of data. So these attributes have information about the environment, like the threat, about the current mission, about the sharing participants. And then you have a set of policy rules which are conditional, and you have decentralized administration with delegation. And a lot of the work that, for instance, Professor Lee's done provides the foundations for dealing with this kind of framework. Now, there are some additional elements when one wants to move this into a web-based framework, is that these need to be combined with cryptographic protocols. They need to be made web services aware. And there's some research going on at MITRE, for instance, on combining these three aspects of the problem, on taking trust management work and cryptographic protocol work and web services work and combining them into a single framework. Now, a lot of the work on risk-based access control was spawned by a report by the JSON group, and this has actually been written up as a MITRE technical report, where the idea is that let's say you have a system where you have tokens, and tokens represent the risk of a sharing transaction. Now, these tokens would be distributed by some central authority via some distribution channels, and every sharing transaction incurs a purchase price. So when you want to access a document, you have to pay a certain amount of risk tokens. And the purchase price is based on how risky is